All right, the title of today's notes is Graphing Sine and Cosine, and our outcome is I will be able to graph any transformation of sine and cosine. All right, so here you have a lot of notes. Just go ahead and take them, and then we're going to work through this. Graphing sine and cosine, y equals a sine bx minus c plus d. This also works for cosine. Step one, we're going to identify a, b, c, and d. Step two, identify the amplitude. Step three, identify the period of our graph, which is 2 pi over b. Step four, identify the counting interval, which is period over 4. Step five, identify the left and right endpoints of our graph. Step six, create a table of sine bx minus c. Step 7, create a table of a sine bx minus c plus d. Okay, so the first function we're going to graph, y equals 1/2 sine 2 theta plus 2 pi over 3 plus 1. So we want to first identify our a, b, c, and d variables. So a is the coefficient of our function, sine or cosine. So in this case, it is 1/2. B is the coefficient of your angle, whether it's theta, x, alpha, beta, whatever letter. So that is 2. C, if you think of parabolas or anything else inside parentheses, it's actually going to be the opposite of what you see. So this would be a shift left of 2 pi over 3, so that's negative 2 pi over 3. And D is plus 1. Right. And that is our vertical shift. D is a vertical shift. Whereas C is our horizontal or phase shift. All right, we're just going to move this over so we have a little more room. All right, so A is used to find the amplitude of your graph, and the amplitude is just really the height. It's from the midline to the top or midline to the bottom of your curve. Okay, so it's just how tall the function is. And that is the absolute value of A. And what we know about absolute value, that answer should always be positive. So the absolute value is 1/2 is 1/2. So that tells me that this graph is 1/2 the height of a normal sine graph. Next thing we're going to find is the period. And our formula for that is 2 pi over b. So we take 2 pi and b, which we already identified as 2, and we reduce. So our period of this function is pi. Right. Now the whole point here is we want to graph all 5 points of this function. So we need to use what is called the counting interval. Just an easy way to find our points. And our formula is period over 4. So you take your answer from your previous step, which was pi, and divide it by 4. And what that tells me is we're going to count by pi over 4s from the beginning to the end of our graph. Okay, so the next thing we have to do is find the left and right endpoints of this function. Like we said, there's a shift. Okay, so it's not always going to start at 0. we're going to take that into account. So for the left endpoint, our formula is bx minus c equals 0. Right? Now, what this means, bx minus c, it's that part of the equation. It doesn't mean that it's always subtraction. So bx minus c, if you remember, is what's in parentheses. So 2 theta plus 2 pi over 3 is equal to 0. Okay, and we're going to solve for theta here. So first thing we're going to do is subtract 2 pi over 3 from both sides. So I have 2 theta equals a negative 2 pi over 3. And then we're going to divide by 2 on both sides. Okay, so we can't divide a fraction by a fraction, so we're technically going to keep change flip. Negative 2 pi over 3 times 1/2. So I'm going to cross reduce, and it looks like I have a negative pi over 3. So that's where my left endpoint of my graph is going to start. All right, next we're going to do the right endpoint. So after the shift, this is where our function will end. And it also has its own equation. Bx minus c is equal to 2 pi. And if you think about if I started at 0 for the left and ended at 2 pi, that would be one cycle of the function and also one cycle of the unit circle. So 2 theta plus 2 pi over 3 equals 2 pi. Subtract 2 pi over 3. So if you look here, it looks like we're going to have to do some subtraction of fractions. So we're going to put 2 pi over 1. And anytime we add or subtract fractions, we need a common denominator. So I'm going to multiply by 3. So 6 pi over 3 minus 2 pi over 3. And that's equal to 4 pi over, I promise that's a 3. Give me a second. 3. So we have 2 theta equals 4 pi over 3, and we will divide by 2. And the same thing here, keep change flip. So 4 pi over 3 times 1/2. Cross reduce. I have a 2 pi over 3. So this tells me that my function is going to go from left negative pi over 3 to right 2 pi over 3. All right, for our next step, we're going to make our chart of our 5 points so that we can actually graph this. So we're going to take our x values, which are just going to be my left endpoint, which is negative pi over 3. And I need to get to my right endpoint, which is 2 pi over 3. And so this goes back to that counting interval. This is where it comes into play. I'm going to count. If you remember, our counting interval was pi over 4. So we're going to start at a negative pi over 3, and we're going to count by pi over 4s until we get to 2 pi over 3. So negative pi over 3 plus pi over 4. Adding fractions, need a common denominator. So our common denominator is going to be 12. So we're looking at a negative 4 pi over 12 plus 3 pi over 12. Which is pi over 12. So actually negative pi over 12. Okay, so then we're going to take negative pi over 12 and add, work over here, negative pi over 12, and we're going to add another pi over 4. Okay, but if you look back at, since I'm adding pi over 4 each time, and we already know this is what pi over 4 looks like with a common denominator of 12, I'm actually adding 3 pi over 12 each time. Negative pi over 12 plus 3 pi over 12 is a positive 2 pi over 12. And 2 pi over 12 reduces to pi over 6. Even though I'm reducing it to pi over 6, I'm going to use this 2 pi over 12 since it's already a fraction of 12. And I'm going to add 3 more, which is 5 pi over 12. And then 5 pi over 12 plus 3 pi over 12. 8 pi over 12. Which does reduce down to 2 pi over 3. And that was our right endpoint. All right, now I have my 5 points. We're going to go ahead and complete the rest of our table. So this next part is actually 2 theta plus 2 pi over 3. Or it's the bx minus c part of your function. All right, and these values for sine, they're always going to be the exact same points. They're going to be 0, 1, 0, negative 1, and 0. And remember I said we're doing a period of the sine function coming from the unit circle. So if I look at, on the circle, sine of 0, our coordinate is 1, 0. So the sine is the y value. Here we have 0, 1, negative 1, 0, 0, negative 1. So the values are the y values as it goes around the unit circle and back to 2 pi. So 0, 1, 0, negative 1, 0. So this column will always be the same when we're graphing sine. And when we graph cosine, it'll be the x values as it goes around the unit circle. Our next column, we're going to add a and d. So this is the 1/2 of sine plus 1. Go ahead and get rid of this real quick. A and d. Okay, so since we already solved for bx minus c, we're just going to take our values of sine and plug them in. So 1/2 of 0 plus 1, 1/2 of 1 plus 1, 1/2 of 0 again plus 1, 1/2 of negative 1 plus 1, and 1/2 of 0 one last time plus 1. Okay. And our final answers will be our y values. So 1/2 of 0 is 0 plus 1 is 1, and that will be in those 3 places. Half of 1 is 1/2 plus 1 is 1/2 or 3/2. Not the same. 1/2 of negative 1 is negative 1/2 plus 1 is a positive 1/2. So these x and y values are your coordinates for your graph. Each one of these would be an ordered pair for your graph that we're getting ready to graph. All right, so if you remember, our counting interval, once again, was pi over 4, and when we added, that was a 3 pi over 12. So that's going to help us when we set up our graph here. So a negative pi over 3, whatever distance that is, negative pi over 3 is technically negative 4 pi over 12. So if I'm on my interval, whatever I set this at, if this is my negative pi over 3, okay, once I count after that, 4 pi over 12. All right, my next point's actually negative 12, so I'm going to move this pi over 3, or the graph itself. Okay, we're going to leave. We're just going to move the actual graph, pi over 3. Negative pi over 12. And then whatever space is in between the negative pi over 3 and pi over 12 needs to be consistent throughout, because remember, counting interval, that distance was the same. So this would be my pi over 6, 5 pi over 12, and 2 pi over 3. Now on the y-axis, my highest value is 1.5, and my lowest value is 1/2. So everything's going to be in the first and second quadrant. So I'm just going to count by halves. Okay, and I'm just making my graph fit my chart. So negative pi over 3 and 1. Negative pi over 12 and 3/2. Pi over 6, 1. Five pi over 12, 1/2. And 2 pi over 3, 1. Okay, and these, when you connect them, they're not straight lines, they are curves. Think of the circle. If I'm taking the circle and I'm breaking it apart, it's a curve, it's continuous, but we're not doing all of the graph. Okay. I'm off a little bit here. But that is your curve that represents this function. It's one cycle. So from negative pi over 3 to positive 2 pi over 3, this is what one complete cycle looks like. All right, guys, I know that's a lot there, a little overwhelming. This is about as difficult of a problem as you can get, especially dealing with the different fractions and finding your common denominators. So we will end there. Tomorrow we will work on cosine and clean this up a bit.